as we start to think about making our very first visualization, we have to ask ourselves, what do we actually have to make it with? Like, what design elements do we have control over? If we're painting a picture, what colors do we have access to? If we're building a building, what tools do we have in our kit? We have to know what we have in order to think about what we might make. These design elements are really key, and actually there's not very many of them. So we may have, I don't know, 8, 9, 10, kind of depending on how you're going to count a few things. The most important, well, let's just go through all of them. So we have position, like where the things are physically, where the marks, so these, we'll call each one of these a mark, are physically located. We have the length of an object. We have the angle or slope of a line. We have area, which is two-dimensional kind of extent. We have volume. Now remember, these depictions are going to be two-dimensional, meaning we're going to be looking at them on a screen. So you're trying to display volume, a three-dimensional concept on a two-dimensional surface, and this can get challenging. We'll talk about this. Here, this is called difference. We'll call this shape, the shape of the mark. And then I want to distinguish the following three pieces here. And we're only really going to talk about two of them. The hue, which is the actual, we would call it, I think most people would call it color. It's the actual different color, like red, orange, yellow, things like this. There's the saturation. The saturation is the intensity of that color, ranging from that solid color down to white. This is the color saturation. And then there's the contrast, which is the darkness of the color. So you might add some like from lighter to darker. The ones that we really are going to care about are saturation and color hue. So hue being, again, just the color itself, and the saturation, kind of where you are on this color spectrum from pure color to pure white on the other side. And we're going to see that even having this distinction between hue and saturation is incredibly important in data visualizations because they have fundamentally different purposes. So these are really it. We're not going to use texture. Texture is not a feature of Tableau, and even contrast really isn't a feature of Tableau, nor is volume. So most of these are not too big of an issue. We only have so many things to play with, which is just, to me, like endlessly fascinating. Because if you think about it, it's kind of like, it's amazing to read a novel or something and think that every novel you've ever read is only the combination of so many individual words. In the same way, every visualization you look at, no matter how impactful it is or how unique it seems, is only the combination of just these few pieces together with the data. But it's from a design element perspective, there's not actually very much going on. There's just a few things, but they can be combined in like endlessly creative ways. This is not new stuff. This is actually really old stuff. People have been looking at this for a long time, thinking and trying to understand from an experimental, empirical, quantifiable approach how people actually discern these things. Are people better at distinguishing color or size, like shape or length, things like this? So there's a link here to this Cleveland and McGill paper, and they have several in this vein, and there's many, many others. I'm just showing you one here, showing how far off people were from the true value when the numerical quantity, for instance, was displayed by position on a common axis or non-aligned axis. We'll talk about what these are. Displayed via length or via angle or via slope. This angle here, or sorry, this axis here is the error. So the farther we go to the right, the worse the person was at guessing the true value. So this is saying the best way to display a numeric variable, quantitative variable, is with position along a combined axis. Length next, angle next, then slope, then area, then blob. Circle area, then blob area. So if we take all of this stuff that Cleveland, McGill, and everyone else has told us, we get the following super, super, super critically important chart, table, let's say. I say it's critically important, like we have to know this stuff almost cold turkey because it's just so critical, and it tells us in preferential order if you're trying to display this variable, what's the best way to do that. For instance, if I'm trying to display a nominal variable, what's the best way to do that? Position first. Always position first. And in fact, position is the fundamental quantity. Where I position my marks is critically, critically important. Then after that, what do? Well, if it's a nominal variable, you go with hue, meaning the color. If it's an ordinal variable, though, you go with saturation. And why might we want to do that? Because the order of the ordinal variable is indicated by the saturation of the color. So the more saturated you get, the higher up in the ordering. The lower the saturation, the lower in the ordering. So remember, that's what I was kind of saying, like the difference between hue and saturation is fundamental, and it's fundamental because one of them is ordered and one of them is not. So on and so on and so on. So we have all of these different pieces, but like it's really critical, important, and like let's go through and actually see an example here where we can kind of do this. So imagine we're trying to show a nominal variable, so that in this case is cell phone manufacturers, so we have Apple, Huawei, LG, and Samsung, and we're trying to display with that nominal variable a numerical variable in terms of the count, how many people actually have a phone of this type. So we have two variables in this plot, a nominal variable and a discrete numerical variable, and here we're showing it through a bar chart. A bar chart is probably a chart that you've seen before. It's just well, let's put it in precise terms. It is a chart in which we have a nominal categorical variable on one axis, a discrete numerical variable on the other axis. It doesn't have to be discrete. Typically, it's discrete. It could be continuous, and this thing is displayed by length. Like the numerical variable is displayed by length, and the position on this axis is denoted by denotes the nominal variable. So let me just say that whole thing again, because this is probably much more precision than we've been thinking about visualizations in the past, but this is the type of thing that we need to get in the habit of doing. This is this visualization's fingerprint. A bar chart is a chart that shows a nominal variable along one axis and a numerical variable on the other axis, with the length along the numerical variable representing that numerical variable, and then on the other axis the position indicating the nominal variable. So like I said, there's a lot going on here, but even more than that, we have to ask ourselves, what's the intention of the visualization? So this brings us back to that first question about what's the point, what's the context-driven business question you're asking. And if the context question is kind of what does the overall picture look like, then you might want to list these things in alphabetical order so that, for instance, a stakeholder could quickly look up LG. They don't have to look through the entire list. They know it's alphabetized. They scan through, they find LG, and they're good to go. If, on the other hand, your purpose or your question was, what are the top selling phone brands? And that was the question you're asking yourself. Same data set, same data, but different question, then you might want to organize this axis not alphabetically, but by count. I know that seems silly, but like this is the type of thing that distinguishes a just okay visualization from a very high quality visualization, is tying that business question in as much as you can. But notice that we're not quite done there. If we go back to our like best list here, this numeric variable, so we're coding our nominal variable by position. Okay, that's fine. But notice that length here is lower on the totem pole, lower on our preference list than position. So what this is saying is I'm showing this numerical variable by position, but actually it would be more effective, and people would have better reasoning if instead I showed this as just a position. So I'm no longer looking at this as length. I'm actually just putting the position of the mark at the appropriate value. I know this, again, I get that this is probably seeming much more detailed than we're typically used to, but this is the kind of detail that we need to get into if we're going to be kind of making visualizations that people say, I don't know why this works so well, but man, this works well. You know, like I don't know how they did this, but man, it looks really, really good. These are the types of decisions that people are making in the background all the time. So here's a very similar situation. We have undergraduate, graduate, and high school. The only difference here is that the horizontal variable here, the variable on the horizontal axis, is now ordinal, meaning it has an ordering, undergraduate, graduate, and high school. Except things are not in the right order. You know, like this is not appropriate. We need to obey the ordering here. So in this particular case, like it's unless you have very good reason, the ordinal variable should be in order according to the ordering the inherent ordering that it possesses. So finally, if we have something it's more like this, so here we have a more complicated picture, right? We have actually three variables going on at the same time. We have a numeric variable that is the number of months since month 0, whatever that represents. That's a numeric variable. We have a numeric variable that is sales. And notice that I have two axes here, but that is relating to a third variable, which is location. And so location in this situation is we'll call it a nominal variable. We have location 1 and location 2. So right now, these are being represented by position, like they are separated, but they're separated and not aligned. So what I mean by that are non-common or not dual or something like this. What I mean by that is, notice that both the x-axis and the y-axis in both of these situations, in both of these graphs, are not common. So if I'm trying to make a comparison about what's going on in month, let's say month 15, or let's do month 16. So month 16, I have to look here, and then I have to figure out, okay, month 16, I don't know, that's like 10 or something like this. And then I have to say, okay, month 16, but I look in the same place, but that's like month 21 down here. So okay, now I gotta go here, and then I gotta go over here. It's like there's so many needless comparisons that have to be made, when instead I should just be putting these things on a combined axis. So first of all, I should line these things up. So here I've just lined up the horizontal axes. So now they both go from 0 to 25. I should also align the vertical axes so that they're both, in this case, 0 to 150. But then I can also just put them on the same plot and give this, instead of having two separate plots, I can actually put them on the same plot. And now these trends and comparisons that might otherwise have been very, very difficult to make are completely obvious when we've made these things, made these axes align. We'll see how to do this in code without much of a problem. So the big idea here is, do not assign design elements to variables at random. There is a logic, and that logic is captured by that table. Position, then hue or saturation or length or whatever. This is where the rubber hits the road. We have to kind of follow these guidelines if we expect to have compelling visualizations. Even when we follow those guidelines, things are often much more complicated than we might think. There are other considerations, in particular considerations related to the business question that we have, that need to be brought into the conversation as well. So things like, am I trying to show comparisons, or am I trying to make it easy for lookup? Am I trying to accentuate the differences between these groups, or show each group individually, or something like this? The big idea is, regardless of what you do, you're not going to get it right the first time. And I say this as someone who gets things wrong all the time. All you can ever hope to do is make it better as you go along. And so the big idea, and we will practice this over and over and over again, is build it, iterate it, and improve it. Get feedback, make mock-ups, ask yourself, really interrogate yourself about what the purpose is, and try to make things better as you go along. And like I said, lots of practice will be forthcoming. So coming right up, we're going to make our very first visualization using all of these principles, and I will make sure to kind of draw your attention to all the different ways we're going to use these McGill and Cleveland best practices in our visualization. So we'll do one in particular, but then we'll be off to the races making visualizations for the rest of the semester. So stay tuned.